In this video, we're going to have a look at part B of the 2011 paper. The question 9 on chemical equilibrium. Once again, you can see here that a pink solution was formed when crystalline cobalt chloride was dissolved in deionized water, and the following equilibrium was established. Concentrated hydrochloric acid was added carefully, drop-wise. Hydrochloric acid would give us the chlorine ions, until the color of the solution changed lilac, which is a pale violet, so somewhere between the pink and the blue. A small volume of the lilac solution was placed in each of 4 test tubes, A to D. Test tube D was kept as a reference. So the first question that is there is explain the lilac color in test tubes A to D. Well, that's because it's this chemical equilibrium that's established, this forwards-backwards reaction, which is an intermediate. The forwards reaction's constantly going, the backwards reaction's constantly going. This lilac color is between blue and pink, so that is why we have that color. Part 2, the color that appeared when a few drops of water were added to test tube A. So we have this system in each of the test tubes. If you're adding water, you're adding a stress. So you're going to move the equilibrium away from the side that you added the stress to. If you're adding water's here on the right, so it's going to move to the left, away from that stress. So the color that would appear is pink. It's going to move left, away from the water that was added. That's part 2. Part 3, the color that appeared when a few drops of concentrated hydrochloric acid were added to test tube B. Again, each test tube has this reaction in there. But if you're adding concentrated hydrochloric acid, it's going to supply extra Cl- ions. And that's going to move the equilibrium the opposite direction to where the chlorine ions are. So in test tube B, if you're adding hydrochloric acid to it, it's going to supply chlorine ions, and that'll move the equilibrium over here. So the color will go blue because it'll move the equilibrium position forwards. When test tube C was placed in a beaker containing ice and water, the solution in the test tube became pink. Is the forwards reaction exothermic or endothermic? Justify your answer for 9 marks. Okay, so this is where we have a look at the equation itself, and we try to establish what would make more sense. So test tube C being placed into ice and it becomes pink. Okay, so you could do this. What I like to do is I just like to suggest it's exothermic for a start. Okay, if we were to suggest it's exothermic, our heat would be over here on the right. If the forwards reaction was exothermic, the heat would be one of the products. Now, if we heated this up, it would move to be pink because it would move away from the heat. Now, the opposite is true. It moves to the pink. It turns pink when you cool it down. So the heat mustn't be at this side. The heat must be at this side. So the guess, or the suggestion would be that this is endothermic. And why? It's because, again, a stress is applied and it moves away from the stress. So if we're not right by saying it's exothermic by putting the heat there. If we put the heat here on the left and made it an exothermic reaction now going forwards, if we heat it up, it'll move to blue. If we cool it down, it'll move to pink. And that does make sense here. So is it exothermic or endothermic? It's endothermic because it moved away from the stress that was applied to it, in this case, reduced temperature.